Hello, Doofer911 here, and today we're going to be looking at the next step in our procedure guides for this aircraft, the PMDG Boeing 777. So in this video, we're going to be taking a look at the CDU setup, or the Computer Display Unit setup. We are going to be using the CDU, to interact with the aircraft's flight management computers and flight management system. What we'll be showing you today is how to enter in details about the aircraft's planned flight path and also enter in performance data for the aircraft. So before we can do any of that, we need a flight plan to work with. So what I'm going to do just now is jump out of the simulator and show you the flight plan that I've just created. Okay, so here we are on simbrief.com. So this is a fantastic tool for any flight simmers who want to generate realistic looking flight plans for their flight simulation flights. The website is amazing. I highly recommend it to anyone. I'm not getting paid to say that. It's something that I've used for many years during my own flight simming. It is free to join the website and create an account, so I would highly recommend it. As I said, it's a fantastic tool for flight simmers. Anyway, for this procedure guide series, what I'm going to be doing is I'm going to be flying from London Heathrow to Las Vegas in America. And I've already generated the flight plan here, and I'm only going to cover some of the key points that I want to touch on for the CDU here. If you want some more detail about SimBrief and how it works, I highly recommend you click in the top corner and check out the video that I've done on it previously, where I talk a bit more about the website and how it works and what it can offer to you. So there's a couple of details that we need to begin with, and then we'll refer back to the flight plan as we go through the CDU process. But there's a couple of bits of information we want to begin with before we get into that. So the first one is the block fuel amount. So this is the total amount of fuel that's going to be loaded onto the aircraft while it stood at the gates at Heathrow. So you can see here that SimBrief has given us a block fuel amount of 184,988 pounds of fuel. Now I'm going to make that nice and easy on myself, and I'm just going to round it up to 185,000 pounds of fuel. So I'm just going to make a note of that on a piece of paper that I have here, because we will need that in a moment. The other two pieces of information that I'll need will either be the number of passengers and also the payload amount on the aircraft. So I'm going to scroll down here to the printout of the flight plan, and I'm going to scroll down, and I believe so we have a section here called weights. And the first number that we have here is packs or passengers. So we have 222 packs on board, which is absolutely fine. And then we're going to take some of the weight loadings here as well. So we've got 3,200 pounds of cargo, which I'm going to make a note of here. And then our payload, our total amount of kind of baggage there, will be 54,300 pounds. So 54.3 for the payload. And what it's also worth doing is making a note of the ZFW, or the zero fuel weight there. So that's come out at 398 pounds, or 388,500 pounds. So 398.5 zero fuel. Excellent. Now, what I would recommend is, if you are using simbrief.com, would be to download the flight plan files and then load them into the folders on your computer for the PMDG 777. What this will allow you to do is to automatically upload the flight plan to the aircraft, rather than sitting and entering all the waypoints and airways manually. Just saves a little bit of time, and particularly when you're doing long haul flights, it's just more of a convenience loading the flight plan automatically. So the two files that you will need here will be the PMDG flight plan, so you would want to download that, and then also the PMDG wind uplink, and you'll also want to download that as well. So once you have downloaded those, you'll need to move them into specific folders on your computer. So what you want to do is you want to navigate to your main simulator install folder. So for me, I'm using prepared version 4 or P3D version 4. I've got that on my C disk here. So go into that folder, and then I'm going to go into the PMDG folder. Now I'm going to go into the flight plans folder here, go into the specific aircraft I want, the 777, and I've already done it here. You can see that the flight plan will have your departure airport followed by your arrival airport, so EGLL Heathrow to KLAS Las Vegas, and you can see with the date modified that that's today's flight plan. So that would be the PMDG flight plan file that you would need to put into there. For the wind uplink, that would need to go into a different folder. So if I just back out here, so in your PMDG folder within your simulator install, you've got this WX folder for weather. If you click into that, you can see here I've got eglklas.wx, so that's the wind uplink file for this flight. So once those two files are in the correct location, you can close that down and we can return back to the simulator. Okay, and here we are back in the aircraft. So you can see here that I've just changed the view up, just so we've got a better view of the CDU here. So what we're going to do before we do any of the flight preparation is we need to go back into the the simulator's options page, and we need to load in the amount of fuel and passengers and the payload that we just picked up from the flight plan. So to do that, we need to go into FS Actions, and then you can see here we have an option here for fuel and payload. So what I'm going to do is I'm going to go into the fuel page first of all, and what we want to do is we want to enter in the block fuel. So this was the total amount of fuel that was going to be loaded onto the aircraft for the flight. So if you remember from our flight plan, we were given a block fuel amount of around 184,000, which I, just for convenience, rounded up to 185,000 pounds of fuel. So I'm going to come down to the keypad here and I'm going to type in 185,000. So that's 185,000 pounds of fuel. Now some aircraft might be measuring their fuel in kilograms, so just be aware when you generate your flight plan, just be aware of which measurements the aircraft is using. Is it pounds or is it kilograms for the fuel weights there? So once I've typed that in, I'm going to press the button next to the total amount here, and that's going to load in that amount of fuel into the aircraft. So what I'm going to do now is I'm going to return back to the previous page here, and then we're going to go into the payload for the aircraft. Remember, this is sort of an options page for the aircraft. This isn't what you would see in real life in the real 777. So the first value that we picked up from the flight plan was we were going to have 222 passengers. Now you can see here on the top three lines we have first class, business and economy. So this is how we can sort of distribute the total number of passengers amongst these various classes within the aircraft. So I'm just going to do this very roughly. Just going to say 170 into economy there. If we put, let's say, 40 into business class there, and then let's say 12 into first class there, and if my maths hasn't failed me, that should be 222 passengers in total, which I think it is. Okay, so that's us loaded in our various passengers into our various locations on the aircraft. What we want to do now is we also want to add in the sort of the payload here in the forward and aft cargo, and then if we had any dedicated cargo amounts, this would go into the bulk cargo. So the next value that I have here was cargo, which was 3.2 or 3,200 pounds. So I'm going to put that into the bulk cargo section there. And then for the forward and aft cargo, so we had a total payload of 54,300 pounds. So if I roughly divide that into 2, that would give us, let's say, 27.1 each. So I'm going to put 27,100 pounds in the forward section, and then I'm going to do a forward slash and do the same amount again in the aft section. There. Okay, and you can see here on the right we have some more numbers which are being updated as we update the weight of the aircraft here. So we've got our gross weight, max takeoff weight, and we've also got our zero fuel weight, which is quite considerably different from what our flight plan is. So just be aware that they might not always add up. But the important one here is we can see the load level is about 86.3% of the maximum load for the aircraft. So we're still within safe limits for operation here. So with that, what I'm going to do is I'm going to return back and return again until we're back to the sort of the route menu on the menu page of the CDU here. Okay, so what we can do now is we can actually go into the FMC. So this is representative now of what real pilots would see on the actual CDU in the actual aircraft. And this also marks the beginning of the CDU setup procedure. So the first page that we're going to receive here is going to be the ident page, and we want to check the details on this page to make sure that everything is correct. So the first thing, we're going to check the model, and we are definitely flying in a 777-200, so that is correct. Basically what we're double checking is we're making sure that the firmware which has been loaded onto the aircraft's computers matches the actual aircraft that we're flying. You know, if we saw, for example, that we had an Airbus A320 software loaded into our Boeing 777, then we'd know that the software doesn't match the aircraft, and that could lead to horrific issues. So that's why we're double checking this data here. Next, we want to check the engine rating. We want to make sure that the performance data that the computer has matches the engines which are actually installed on the aircraft. So the 777-200 does use GE19 engines, so that is all correct there. Lastly, we want to make sure that the nav data that we have is correct, which in this case it is. Now, to get up-to-date nav data for a flight simulator, it is a paid service in most cases. I personally use a company called Navigraph, and I subscribe to their service, and they provide me with up-to-date nav data every month. Now, it's not essential for flying in a simulator. You can do flights with out-of-date data. Just be aware that things such as various waypoints and airways and some airport data may be out of date, like frequencies for an ILS, for example. Those are the sort of things that would be associated with out-of-date nav data. As I said, it's not the end of the world, but do be aware that that could be an issue. You will also receive a little message along the bottom here if your navigation data is out of date. Okay, so with that marks the end of our checks on the ident page. So what we want to do now is move on to the POS init page, or the position initialization page. So what we're going to be doing on this page is we're going to be telling the flight computers where the aircraft is in the world. If you watched the previous video, you would have seen that we went through the ADIRU sort of setup and initialization process. So what that's done is that's worked out the orientation of the aircraft, you know, which heading it's facing, whether it's pitching up or down or rolling left or right. So all of that has now been completed, but the aircraft still doesn't know exactly where it is in the world, and that's what we're going to we're going to use this page, the position initialization, to tell the aircraft where it is. Hence why we have the enter inertial position message at the bottom. So the first thing that we need to check on this page is we need to make sure that the UTC time is correct. Now be aware, this will be the UTC time in the simulator. It's not going to be the UTC time compared to real life. It's whatever time you have the simulator set to. What we can do is we can enter in the reference airport. So this will typically be the airport you're departing from. In this case, we're going to be departing from London Heathrow, which is its ICAO code is Echo Golf Lima Lima. So we just type that in on the keypad here, and then enter that into the ref airport there. And you can see that it gives us some coordinates based on the position of the airport in the world. Now we're not going to use this position here, we're going to pick up the GPS position from the aircraft. So to do that, what I'm going to do first of all is just hit clear, just to get rid of this message along the bottom. Now what I'm going to do is I'm going to click on the next page button here, and that brings us onto the next page, which gives us some GPS information about the aircraft. Now this third line here, GPS, this is the GPS position that the ADIRU system has calculated the aircraft's position to be. So what I'm going to do is I'm going to press the button on the left next to GPS, and that's going to copy the GPS position down into the scratch pad, the little essentially text box at the bottom here. I'm going to go back to the previous page, which was the initialization page, and you see that the GPS coordinates carried over as well. What we're going to do now is paste that number, or paste those details, into the set inertial position line here. So simply tap the button next to that, and it sets the position there. Now what I'm going to do is I'm just going to change my view quickly here, just so you can have a look at this. So if you watched the previous video, and if you were watching closely at the start of this video, you would have noticed that the primary flight display and the navigation display were not active. They didn't have any information on them. It's only once you enter the aircraft's position and confirm it that these two displays become active and they become ready for use. Okay, so once the CDU initial setup has been completed, we can now move into the process of entering navigation data into the flight computers. So what we're going to do is we're going to click on to the next page here, which is the route page. So we're going to click into that here, and we can begin entering in our route. So the first step is to enter in our origin airport, or our departure airport. As we said before, we're taking off from London Heathrow, so we're going to enter its 4-letter ICAO identifying code, which is Echo Golf Lima Lima. So just type that into the keypad here, and then paste that into the origin there. Next we need to enter in our destination airport, so we're going to be flying to Las Vegas. Its ICAO code is Kilo Lima Alpha Sierra. So type that in, and enter that into the destination line here. Next we can enter in our flight number here. So I'm just going to be using a fake flight number, so it's just going to be PM for position manuals, PMDG, and 123. And then enter that into the flight number there. Now next step, what we can do is we can automatically load the flight route into the computer. This is why we would have downloaded the flight plan files onto our computer previously. So what we can do is we can tap this button next to route request. Now what that's going to do is it's going to simulate basically receiving the route by satellite data. So rather than pilots sort of carrying a like a USB stick or a floppy disk or some sort of physical medium to the computer to load the flight plan in, basically they're going to send a signal to the airline's operations team saying we're ready for our flight plan. The airline's operations team are going to send the flight plan to that specific aircraft sort of via a satellite link, and that's why it takes a few seconds for it to come through, because it's kind of simulating that kind of wireless transfer of data. So you can see here we heard a little bing bong once the data came through, and we now have a message saying route 1 uplink is ready. So what I'm going to do is I'm going to come over to the route uplink line here, and we're going to load the data into the CDU here. So you can see route 1 uplink is currently loading. I'll give it a few seconds to complete that there. And you can see it's been done, and that's been confirmed because we have a company route of Echo Golf Lima Lima Heathrow to KLAS Las Vegas. So you also see we received a second message here saying performance initialization uplink. We're just going to leave that for the time being. We'll come back to that in a moment here. Once we've received the navigation route here, what we're going to do is we're going to tap the button next to activate that. And then you can see here the little light above the execute button here lit up. So that's basically saying, so basically what the computer's doing is the computer's saying, right, I've just had some information added to the computer, and this execute button is sort of a confirmation. Are you sure you want to load this data? Are you sure you want the flight computers to use this data? We are, so I'm going to tap the execute button there. You'll see we get a few more lines pop up, but that's now confirmed that that is the information that we want to use for this flight. Okay, so once that data has been uploaded and confirmed, the next page that we need to go on to is the departures and arrivals page, which we can access using the departure and arrival button just here. So click onto that, and that brings us up our departures for Echo Golf Lima Lima. Now if we refer back to our flight plan, we can see that we're due to be taking off on runway 09 left. So what I'm going to do is I'm going to come over to the right hand side first of all and select the runway that I'm due to depart from. So that'll be 09 left, click on that. Now the reason I do the runway first is because it then filters the SID, or the departure procedure, that we're going to be using. Now if we have a look at the flight plan again, we can see that our departure procedure is due to be the ULTIB 1 kilo departure. Now if we're having a look here, we can see we don't have that available. However, if we look at the top right corner, we can see that we have one of two pages here. So if we go on to next page, fantastic, there we go, we can see we've got a couple more SIDs available, and there is the LT 1 kilo departure that we want. So I'm going to tap the button next to that to select it, and we have the runway 09 left and ULTIB 1 kilo departures are both selected. Once we've selected our departure runway and our procedure, we are going to press the execute button again to tell the computer and confirm that this is the data that we want to use for the flight path. So execute that, and that's now been loaded into the flight path there. Okay, my apologies, we just had a little cut in the video there due to a technical issue. But once you've confirmed the departure runway and the departure procedure, the next page that we need to take a look at is the route page again. So if we click onto that and then go onto page 2 of 5 for the route page here, what we want to do is we want to make sure that the routing that we have in our CDU here matches the routing that we have on our flight plan. So what we can do is we can bring up our flight plan here, and we're just going to cross-check the routing and make sure that this matches the flight plan here. So we're going to be departing via the ULTIB 1 kilo departure to the ULTIB waypoint, which is correct there. Then we're going to be flying direct to a waypoint called Hemel. Now we don't have that on our flight plan here, but I do know from looking at the departure procedure for this departure procedure off of this runway that Hemel is one of the waypoints that we will be passing through, so I'm not too concerned about that extra waypoint being in there. Next you can see here that we're going to be following the T420 airway to the TNT VOR station. We're then going to be flying along the UL28 airway to Rodol, UM65 to Tenzo. If we move on to the next page to look at more data, we're going to be flying Lima 603 to Remzi, and then direct to Lutov, direct to Resno, direct to Rikal, and then we're going to be passing through the... So this is actually a GPS position that we're going to be flying through. So November 440 Alpha, and we're going to be flying there. So this is actually going to be our sort of transatlantic crossing at this point here. We're going to the YRI VOR station, which is correct there. Then we're going direct to Resin, direct to Seoul, direct to GEP. And then we're going to be following the airway J114 to FSD. And then we're going to be flying direct to BFF. And then we're going to be following the airway Juliet 157, and we're going to go to the LAR and then direct to MLF. So that marks the sort of the end, or this is going to be getting towards the end of our cruise phase of flights. Now, I'm not going to worry about setting up the aircraft for its arrival into Las Vegas just yet, because the flight time is going to be about 11 hours and the weather is very likely to change at Las Vegas. So our flight plan does give us an arrival runway of 01 right at Las Vegas. However, I'm not going to set that in just now because chances are that will change during the flights, and the runway may change and the arrival procedure may change by the time we reach Las Vegas. So once we've checked the main routing for the CDU there, we've made sure that matches what we have planned for on our flight plan. Next, we can go into a bit more detail and take a look at the legs page. So the route page would have given us all of our major waypoints and airways along the route, but the legs page will give us every single individual waypoint that we're likely to pass through. Now, if you want to, you can check all of these against the flight plan here. If I look a bit further down the flight plan, you can see that it gives us all of our specific waypoints that we're going to be passing through on there. So if you want to double check that and cross check all of those, you can. However, if you're staying on particular airways, then you'll be absolutely fine. Something that is important that we do need to check on the legs page is we do need to check the various waypoints along the departure procedure. What we're doing is we're making sure that the aircraft is going to fly its departure procedure accurately. As you can imagine, around London there is a lot of aircraft and it's a very, very busy area of airspace. So we want to make sure that the aircraft follows its departure procedure accurately to make sure that it doesn't come into conflict with any other aircraft flying around the London airspace. So what we're going to do is we're going to take a look at our departure procedure chart here, and we're going to check the data that we have in our CDU to make sure that it all matches everything that we have on the chart. Now, if you're not sure how to read a chart like this, I have done some tutorials about reading departure and arrival charts, so I would highly recommend checking those out so you can read a chart like this and understand what information it's giving you. Okay, so the first leg of the journey here, we're going to basically be climbing straight ahead on the runway heading to an altitude of 590 feet. Once we reach that altitude, we're going to turn left to a heading of 050 degrees, and you can see that this has been put down as an intercept. So what we're going to be doing is we're going to be intercepting the 071 radial away from the London VOR station. So you can see the next waypoint here is Delta 071 Juliet. So that is the radial away from the VOR station, and we want to make sure that we're above an altitude of 3,000 feet at a distance of 5 nautical miles from the VOR station. And you can see that matches up with this waypoint here on the SID, or the departure chart, which tells us that we actually need to be above 3,000 and also below 6,000 feet at this point. Then, as you can see, we're going to be turning left, and we're going to be heading away from the Biggin Hill VOR on a radial of 330 degrees. This actually has it down as 331 degrees, so it's not too big of a deal. But you can see that once we complete the turn, we need to make sure that the aircraft is at an altitude of between 5,000 feet and 6,000 feet at this waypoint here. So you can see that we have 5,000 and above is already selected here. Then, as you can see at the ULTIB waypoint, we need to be at an altitude of 6,000 feet. So you can see ULTIB, we have 6,000 dialed in there. If you click on the next page there, you can see that Hemel and then Bazad is our next couple of waypoints along the procedure there. So once we pass the ULTIB waypoint, we can expect a climb clearance from air traffic control. Okay, and once the departure procedure has been checked, as I said, if you want to go through every other leg and every other waypoint and cross-check those against the flight plan, you're certainly welcome to do so there. Once you've checked all of those to make sure they're all correct, the next page we can take a look at is the progress page. So if we come down to the page selection here and click on progress there, what we want to do is we want to go into the position reference here, and the value that we're looking at is the required navigational performance and also the actual navigation performance. So you can see that our required navigation performance is 1 nautical mile, and the aircraft is currently plotting its position to within 0.06 nautical miles, so it's well within the required performance. And finally, what we can do is we can set up the radio navigation instruments using the navigation radio page here. Now, I'm actually going to do this for this flight just to give you, or just to give us an additional visual confirmation of the departure routing that we're going to be flying along. So if we take a look at the departure charts once again, so you can see that we're due to be following this 071 degree radial away from the London VOR initially, and then we're going to be picking up the 330 degree radial from Biggin Hill. So for the VOR left, we've already got London set in here, but I'm going to dial in 071 as the radial that we're going to be following from there. Valid entry. Okay, I think that might be because this has been picked up automatically, the VOR, to begin with. So just going to clear that out and do 113.60. There we go there. So you can see that's now been put in as a manual VOR entry, and it's a radial of 071 degrees that we want. So that now goes into the course here. And now for the VOR right, if I tune in Biggin Hill, which is 115.1, and then we're going to be following a course of 330, radial 330 away from Biggin Hill, put that in there. Okay, so the reason I've done that, if I change my view back to the virtual cockpit here, I mean, if we take a look at the navigation display, so you can see the pink or magenta line is the flight path that's been programmed into the computer. And if we take a look at the departure procedure, you can see it matches up very closely to what we have. You can see that we're going to be taking off, and then a few minutes after departure we're essentially going to be doing almost a 90 degree left hand turn following the route up to the ULTIB waypoint. Now the reason I've put those VORs there on the navigation page is it's just an additional visual aid for us. So you can see this green line here, this is going to be the 071 radial. Actually, and if I also, oops, pardon me, if I turn on my VOR lines there as well. So our VOR left is coming from the London VOR there, and we're going to be following a radial of 071 degrees, and where that's going to intersect with the Biggin on a 330 degree radial there. So it's just an additional visual guide for us. We know that where we need to be making a turn and following this 330 degree radial away from Biggin Hill before the two lines cross, essentially. So you can see it's just an additional visual aid for us there. Okay, so that marks the end of the CDU navigation data portion of this video. Next, what we're going to do is we're going to take a look at entering performance data into the CDU so that we can be sure that the engines have the right level of performance for the takeoff and the climb. Now what we're going to do is we're going to take a little break actually, and this is going to be a good time in the pre-flight process to obtain a weather report for Heathrow or for your departure airports. The reason we're going to do this is that we're going to pick up some key pieces of information from the weather reports that we're going to need as we progress through this pre-flight setup. So I personally use a sort of additional piece of software called Active Sky, and one of the benefits of that is that I can tune into a particular radio frequency and get an ATIS report for Heathrow. Now if you're flying with real world weather, what you could do is you could simply do a Google search for a METAR report for the airport you're departing from, and that would also give you the key pieces of information that you need. So what I'm going to do in the simulator just now is I'm just going to tune in the radio frequency for the ATIS reports, and I'm just going to obtain the information from that just now. So I believe it's 122.0. Now this information is going to go by really quickly, so please forgive me. I'm just going to stay quiet and listen and just make a note of the weather here.
Echo Golf Lima Lima airport information Juliet 1020 Zulu weather wind 029 at 7 visibility 10,000 sky condition ceiling 1200 broken ceiling 1700 broken ceiling 3000 overcast temperature 16 dew point 13 QNH 1030 advise on initial contact you have information Juliet.
Okay, so just to recap the information there, so the current information identifier is Juliet or J. The key pieces of information that we need here are the winds. She gave them as 029 degrees at 7. I'm just going to round that up to 030 degrees at 7 knots. Visibility was 10 kilometers or more, that was fine. We've got quite a bit of cloud above us at the moment, so 3 layers of cloud. We've got broken at 1,200 feet, broken at 1,700 feet, and overcast at 3,000 feet. The temperature was given at 16 degrees Celsius with a dew point of 13, and the air pressure, the QNH, is 1030 hectopascals there. So we're going to be using some of those pieces of information during the next sort of stage of the CDU pre-flight procedure. So we're going to be entering some of that data in as part of the performance data. But we also need that data for other procedures later on, such as the pre-flight procedure that we're going to be covering in a future video. So now is a good time to get our weather reports and get all of that data ready for kind of future procedures. Okay, so coming back down to the CDU, the first page that we need to go onto is the performance initialization page. Now you'll notice that normally we have an option at the bottom for which page we want to select, but it's not here at the moment. So what we can do is we can go onto the init ref page, and this should automatically bring us to the performance initialization, which it has, which is perfect. Now as part of the data uploads when we received the flight plan, the airline would have simulated giving us some performance data as well. Now what we actually want to do is we actually want to reject that data because from personal experience the data that's given doesn't really match up or work too well with with kind of what you require in the simulator. So what I'm going to do is I'm actually going to reject the performance data there, and you can see it's going to blank out a bunch of information there. Now you'll see next it's given us some wind data for the flights, the planned flight path as well, and that is something that we are going to accept. So to do that, what we need to do is we need to go back to the legs page initially, and then we need to click into route data here on the bottom, and then you see here we have an option which says wind data load. So I'm going to load that data. It's going to take a few seconds to do it. You see it's going to light up the various boxes once it's put that data in, and you see once again the execute button has lit up. I want to confirm that this is the data I want to use, so I'm going to press the execute button. You can see now it's also given us some descent forecast data as well. So what I'm going to do to take advantage of this is we're going to go into the VNav page for the descent forecast, and then we're going to select previous page to go to page 3 of 3 for the descent forecast. We're going to go into the forecast page, and then we have forecast amplink, so we're going to load that there. And you can see there after a second or two it uploads all of that data, and we now have wind information for the various flight levels as we descend in towards Las Vegas there. So to come back to the performance initialization, we need to come back to the init ref page, and we're going to click into that there. So the first value that we're going to enter is the 0 fuel weight. So we could get this off of our flight plan papers, but the simulator can automatically calculate this for you. All you need to do is just tap on the button twice. You tap it once, it gives you your 0 fuel weight there. Tap it again, it enters the 0 fuel weight in there. Next we need to enter in our reserve fuel amount. So what I'm going to do is I'm going to come back to the flight plan here, and I'm going to find the section which relates to our planned fuel. Now I'm going to put this up on the screen just now so you can see it yourselves, and what we're looking for is the reserve fuel amount here, which you can see under the fine res line here. You can see that it's given us reserve fuel amount of £6,119. I'm going to round this up to 6,200, which we can enter as 6.2. So put that into the reserve fuel amount there. So what we're going to do is we're going to enter in our initial cruising altitude. While the aircraft is heavy, it needs to fly a bit lower in the Earth's atmosphere because the atmosphere is a bit more dense and there's more lift that can be generated by the wings while the aircraft is heavy when it's lower down in the atmosphere. As the flight progresses and fuel is burned off, the aircraft will become lighter and lighter and lighter, and jet engines are more efficient the higher altitude they fly at. So what we will do is we will perform step climbs as the flight progresses. So as the aircraft gets lighter, we're going to climb up higher and higher to make sure that the engines work as efficiently as they can, and also the higher up you go, the less air resistance there is, the less dense the air is, means the aircraft can also fly faster as well. However, for our initial cruising altitude, it's going to be flight level 340, or approximately 34,000 feet. So we're just going to enter in 340 there, put that into the cruising altitude. The next value we can enter is going to be the cost index. So this is essentially a measure of how much or how hard the engines work, to say it very basically. This is also a value which is given to us on our flight plan. So if we have a look here, under the cruising system here, we have a cost index, a CI of 114. So just going to type in 114, and then okay, so once that data has been entered, the next page we need to move on to is the thrust limitation page. So what this allows us to do is this allows us to select a thrust limit from the engines, rather than having the engines running at 100% of their power and potential. Now on this page you can see that we have 3 different settings, well 6 in total, but we have full performance for both the takeoff and the climb, or we could derate the performance of the takeoff by 10% and also the climb, and the same again, we could derate the takeoff by 20%. Now why would you want to derate or reduce the performance of the takeoff? Well, mainly it's for preserving the maintenance costs and also the life of the engines. Now these are incredibly powerful engines and they can generate a huge amount of thrust, which is not always needed. So what it is possible to do is it's possible to derate the engines or turn them down slightly so that they only use as much thrust as is needed to get the plane safely off the ground. You don't need to use maximum power all of the time. What we can also do on this page is we can also enter an assumed temperature for takeoff. Again, this is an alternative way of calculating a derate from the engine or for the engines, and this is typically available if you have a third-party piece of software which can calculate the performance of the 777. Now for this flight, if you don't have any external calculators, I would probably recommend that we go for a full performance takeoff. We did have a payload of about 85 or 86% of the maximum payload for the aircraft, so that means that the aircraft will be quite heavy, so we do want to use maximum performance for takeoff. Now me personally, I do actually have an external app that I use for calculating performance for the 777. It's an app on my phone and it's called Toper 777 Free, and it's an app which is available on the Android store, and it's made by a Nikola Jovanovic. So if you have an Android and you're thinking about adding just an additional detail of realism, you can use this app. As I said, it's not essential. You can use the fixed D rates and you'll have no issues whatsoever. As I said, this is just an additional tool that I use just to help me. So I'm going to bring up a couple of screenshots of the app on the screen just now. So what I've done, the text in green allows you to, or it basically represents boxes that you can enter data into. So I've entered in the, you can see here we've got the takeoff performance. So the ICAO, we're departing from Echo Golf Lima Lima. We're going to be departing off of runway 09 left. The int x is basically the intersection, or at what point on the runway are we going to be entering the runway and taking off from. Here it's been put down as full, which means that we're going to be using the full length of the runway. The condition, or cond, is condition that the runway is currently dry. This is another reason why we listened to our weather report previously, so now we know we have this information and we know the condition of the runway. The wind has been entered at 030 degrees at 17 knots, and the outside air temperature is 16 knots, and the air pressure is 1030 hectopascals. So again, you can see the value of getting a weather report before doing all of this performance data. For this takeoff, I'm going to be using the flaps set at 15 degrees. Now the 777 can take off with flaps set to either 5, 15 or 20 degrees. So for this I'm going to be using 15. AC, we're going to leave the air conditioning on for takeoff. The anti-ice is going to be off for takeoff because we're not expecting any icing conditions. And the RTG represents the sort of the standard day rates here. So we could have TO1 or TO2. I'm just going to be using the full kind of standard setting there. I've entered in the takeoff weight of the aircraft, which we would have received from the previous page. So if we come back to the index, we take a look at the performance. So the gross weight of the aircraft will be 629,900 pounds. So that's what I've entered into the calculator here. And if we take a look at the data that's given us back, you can see that it's given us our V1, our V rotate speeds, and also our V2 speeds. Importantly, at the bottom here, it's given us our selected temperature of 66 degrees Celsius. So this is what I'm going to enter in on this page. So type in 66, select that there, and you can see that it's now given us a D-rated takeoff and the engines are going to be running at 86.5% of their full power there. You can see that the full power is available, still selected, and you can see that the computer has automatically armed the climb number 2 profile for the thrust setting during the climb there. As I said, this is all a bit of extra stuff. You absolutely do not need to use this if you don't have these tools available. As I said, because I'm a bit more of an enthusiast, I do use extra tools for this here. So once the thrust limit has been calculated and selected, we can then proceed into the takeoff pages. Now the first thing we want to do is we actually want to jump into page number 2 for the takeoff here. What we're going to do first of all is we're going to enter in wind information. So the wind was coming from a direction of 030 degrees and then / at 7 knots. Type that into the scratch pad, enter that into the wind line here, and there you go. And then it automatically calculates that we have a headwind component of 4 degrees and a crosswind component from the left of 6 degrees. Next we can enter in the reference outside air temperature. Here at Heathrow it's currently 16 degrees Celsius, so we type that in, we enter that into the reference outside air temperature there. And lastly, what we can do, if we want to amend the acceleration height or the engine out acceleration height, we can amend the values in here. So the acceleration height, basically the aircraft is going to climb at the best rate of climb that it can until we reach 1,500 feet. Once we reach that altitude, the aircraft is going to level off slightly and begin to accelerate. As it accelerates, the engines can slow down because the airspeed is picking up. That then means that it's less noise pollution for people on the ground. For this flight, however, we're just going to leave the default values in there, so we're going to be accelerating at a height of 1,500 feet. If we were to lose an engine on takeoff for any reason, then that acceleration would actually occur at 800 feet rather than 1,500. Once the data on the second page has been entered, we can come back to the first page of the takeoff ref and we can enter in our takeoff data here. So first we're going to enter in the flap setting for takeoff. So as I said, we're going to use a flap setting of 15 degrees. Type that in and put that into the flaps line there. Next, we need the aircraft to calculate its center of gravity. So this can be done using a performance calculator. Alternatively, it can be done in the sim for you. Just tap the button next to center of gravity, it will automatically calculate it. Tap it again to enter it there. Now the value of this is that it gives us a trim value. So this is the trim that we can set on the stabilizers or the elevators to make sure that the aircraft is in trim for takeoff. And then once that's been done, you'll see that the V speeds were also automatically calculated by the aircraft. Now the V speeds that I received on my calculator were slightly different. I had 159, 159 and 160. You can see here that this has come out at 160, 160 and 161. So that's absolutely fine. I'm happy with a 1 knot difference. So to select these speeds, what I'm going to do is I'm just going to tap the button next to each of the V speeds here to confirm that this is the V1 speed I want to use, this is the V rotate speed I want to use, and this is the V2 speed that I want to use. Now, you may have an issue where once you enter in your flap setting and your center of gravity that you do not receive any V speeds here on the top right corner of the screen. If that occurs, the chances are that if you've selected a D rate here on the thrust limitation page, that the engine performance actually won't be good enough for takeoff. So if you enter your takeoff data and find that there's no speeds been given, what you need to do is come back to the thrust limitation page and select a higher performance from the engines, and then if you enter your data in again here, it should then give you your V speeds. Okay, so once your V speeds have been entered and your takeoff reference data has been entered, that brings us to the end of the CDU pre-flight procedure. So that's all of the data now entered into the flight management computers, and the flight computers now have everything they need to conduct the flight. So just quickly before we wrap up, there's a couple of other elements that I just want to bring to your attention, just as a confirmation that everything has been calculated and set correctly. So you can see here we've changed our view so that we can see the ECAS display correctly here. So what we've done is, as we selected our either fixed rate, D rate, and also entered our assumed temperature, the CDU calculated our takeoff performance at 86.5% on the N1 there. Now if we have a look at the ECAS here, you can see that we have a D-rated takeoff mode has been selected, and we have 86.5 has been selected above the N1. So what will happen is, as we take off, as we set the engines to their takeoff thrust, the engines will only accelerate to a thrust setting of 86.5, and you can see we've got a green mark on the outside as well as a visual indication there. Now because I used an assumed temperature and entered that in at 66 degrees, you can see that information's also been provided. However, if you just selected a fixed D rate, then you would just have the either takeoff, you would probably have DT01 or DT02 would show up here, and you would not have a temperature there. And also, if we take a look at the CDU again and just take a look at the takeoff ref page, you can see the thrust there is set to 66 degrees Celsius and the takeoff mode is D-TO. So again, it's just an additional confirmation that the CDU, or it's just an additional confirmation on the ICAS display of what the CDU has done, and that the data has been saved and set and it's ready to be used. Okay, so as I said, that brings us to the end of the CDU pre-flight procedure. In the next video, we're going to be taking a look at the main pre-flight procedure. This is where we're going to do the bulk of the work in configuring the aircraft and getting it ready for engine start. So we're going to be spending a lot of time looking at the overhead panel, pressing different buttons, making sure everything is ready. We're also going to be looking at the forward panels and checking a few things there as well to make sure that everything is ready for an engine start and a departure from the stand at the airport. So until the next time, thank you all very much for watching, take care out there, and I will catch you all later.